Hey there, everybody. Welcome back. We're in 15.5 surface integrals for calculus 3. And we just went over the formula for surface integrals. I got it at the top of the page. This is on examples. Let's just jump into some. So our first surface is going to be on the sphere, x squared plus y squared plus z squared equals rho squared. And we're going to compute our surface integral for x squared ds. And so on that surface, we're not doing the volume, we're doing the surface. The surface rho is constant, so we don't need to worry about rho. It's a fixed value. So the variables actually remain for the sphere are phi and theta. And so we're going to set up our r vector is our standard r vector. X equals rho cosine theta sine phi, y equals rho sine theta sine phi, and z equals rho cosine phi. I know I said them in a different order than what's on the screen. I took the partial derivatives because we need to get this RU cross RV. And in this case, it's going to be R theta cross, or R phi cross R theta. Let's set that up. So R phi cross R theta. When we go through it, we get this. So every term has a rho squared and a sine phi. I factored those out like that. And we need the magnitude of it. So we take the magnitude, so square everything there. And then this is all these squared. We can pull the rho squared sine phi out because the square and the square root cancel. And also rho is positive and sine phi is positive for 0 to pi. So we don't need to worry about signs for that. The interior actually just simplifies to 1. So we get rho squared sine phi. This was actually the extra credit problem on your last test. So let's keep going. We've got our correction factor now, our RU cross RV. Now we're going to change this over to R phi and R theta. So that's our next step. So I've got we've got x squared ds on the surface. And since we're switching to the sphere, I started writing everything in spherical. We are doing phi and theta, so it's 0 to 2 pi and 0 to pi. X squared is going to be x as a function of rho phi and theta. And then we got our correction factor. So I replace x with its value, rho cosine phi sine theta. We square it. We've got our correction factor right here. We just calculated this. That's that. And d phi d theta. And multiplying and separating everything out. Rho isn't being integrated, so I just factored it out. And the rest is solving this problem. So once you've got it down to cosine squared phi or theta and sine cubed theta or sine cubed phi. As a reminder, the way to address when we just have something, a trig function squared, sine or cosine, is to use the cosine 2 theta formula. Cosine 2 theta has a bunch of variants, but the one we're using here is 2 cosine squared theta minus 1, and we solve for cosine squared. It also has 1 minus 2 sine squared theta, which is the one you would use if this was sine squared. So we make that substitution for cosine squared here. I've got 1/2 1 plus cosine 2 theta. There's that substitution. Here I broke off sine cubed into being sine squared phi times sine phi. And we use a basic trig identity to get that. And so going forth, we've got 1 times that is sine phi. And then we've got negative cosine squared phi times sine phi. You do a U sub on the cosine phi. And when you're done integrating, you're going to get these at these limits. Please make sure you get them when you do it. And when you're all done, you should get 4 pi over 3 times rho to the 4th. So if you need to, pause this, write it down, make sure you get it. And I will catch you in the next video. Peace.